Problems 10 through 15 are, well actually 10 through 12, cosecant secant. A little bit challenging just because it's a little bit different, but just one extra step really. But as I indicated here, first graph y equals sine. So since cosecant is 1 over sine, we're first going to graph the sine, and from the sine we'll be able to graph the cosecant. Okay, so we're just going to answer all these same questions based on the way we've been doing sine and we've been graphing sine and cosine. For example, amplitude is 1, period is 2 pi, and the phase shift is negative pi over 4. So we can run through this one pretty quickly. Go ahead and draw this here. Negative pi over 4, so leaving room on the left. Amplitude of 1. And we get, again, we have 2 pi. Okay, so 2 pi, we divide that, our interval, into 4 equal sections, pi over 2, and 3 pi over 2. So here's where we draw the sine graph. Okay, sine graph, we know it looks like this. We've done this a million times now. Okay, shifting it to the left, pi over 4 radians, becomes a little bit of a challenge because our x-axis is not marked off in pi over 4 radians, pi over 2. So let's go ahead and let's put it in red. So we have negative pi over 4. We have pi over 4, but at least it's pretty easy. 3 pi over 4, 5 pi over 4, and 7 pi over 4. Those are our key values. Okay, where now our red graph, if this were going to be where we're ending up at the sine of x plus pi over 4, we'd draw the red graph solid, but we still can't draw it solid because we're not done yet. Okay, but let's put our 5 key points on this graph. Okay, 5 key points would be, again, the 5 key x values are the ones in red. 5 key points are the ones in red. Okay, so let me erase all those. But you saw them, at least, so you know what I'm talking about. And then we draw the graph dotted. Okay, so this is the graph of sine of x plus pi over 4. Okay, now we know that the cosecant is 1 over sine. Okay, so let me go way back up here and write equals 1 over the sine of this thing. Okay, and so we know that the vertical asymptotes then, just like the cotangent and tangent, we're going to have vertical asymptotes where the sine of that thing is equal to 0, and we can clearly see those values right here. What color have I not used? Let me go ahead and use purple here for our vertical asymptotes. We can see that the sine is 0 here, here, and here. Okay, and that's where we have our vertical asymptotes on the graph of the cosecant. Okay, so vertical asymptotes. That wasn't a very good one, but nevertheless, that's where the sine is 0. Okay, and then we also have our low and our high points for the cosecant, where the sine has its high and low points. So let me clarify that. Here we see on the graph where x is equal to pi over 4, on the graph of the sine is 1. Well, we know that cosecant is 1 over the sine. And if the sine is 1, then 1 over 1 is 1. So that point right there is actually also on the graph of the cosecant. It's the only one, besides this negative one. So we have 1 and negative 1 where the sine and cosecant have the same values. Okay? So then that's the second thing we do. And then we use a little bit of reasoning here. And we say, look, since the cosecant is 1 over sine, let's say the sine is 1/2. Okay, well, if the sine is 1/2, cosecant is 2. If the sine is 1/3, cosecant is 3. Sine is 1/4, cosecant is 4, and so forth. And what that does is it creates a graph that looks just like that. Like an upside down parabola over here, a right side up parabola on between the first two vertical asymptotes, and that green graph that I just drew is the actual graph of the cosecant of x plus pi pi over 4. That's it. That's how you do it. Okay? Alright. That's what they look like. And the secant you'll see is a u and an upside down u when you use the cosine first. Draw the cosine first. So let's do that. Okay, so first we're going to graph y equals the cosine of x minus pi over 4. Okay, where we have an amplitude of 1, period of 2 pi, a phase shift of pi over 4 radians to the right. Okay, so we're going to draw this pretty quickly now. We have a period of 2 pi, cut that in half, we get pi, cut that in half, pi over 2, and halfway between pi and 2 pi is 3 pi over 2. Okay, drawing the graph of the cosine of x, we know that cosine of x is 1 when x is 0. Okay, so we have the graph of the cosine. Okay, so we have the graph of the cosine. We're shifting this graph pi over 4 radians to the right. What color did I use? I used red. So pi over 4 radians to the right, we have pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, and 9 pi over 4. Okay, and we have our key points, 1, 2, 3, oops, get the key point there, 3, 4, and back up here, 5. Okay, and we draw our graph. Okay, there's the graph of the cosine. Okay, dotted lines because we're not done, because now we know the graph of the cosine, we know the graph of the secant. Where the cosine is equal to 0, we have vertical asymptotes. Refer back to what I said about the sine being 0, vertical asymptotes and cosecant. Okay, vertical asymptotes there. That was a very good one. And then where we have high points on the graph of the cosine, we have low points on the graph of the secant, and then we have this upside down parabola here. And then we could keep going over here, but we didn't draw anything over this way, so we don't need to. There you go. There's one period of the secant function between x equals pi over 4 and x equals 9 pi over 4. And there you go. Very tedious, I understand. Alright, let's see if we can do this one. Amplitude is 3. Period is 2 pi over 2, which is pi, and we have a phase shift. This is a pain phase shift. So we have negative pi over 6, because I can tell already it's going to be a pain. And we're going to graph 3 sine first. Okay, 3 sine first, and we're going to go pi is the period, so we're going to section this off. Pi there, cut that in half, get pi over 2, cut that in half, pi over 4. And we have 3 pi over 4. Okay, our period is 3, negative 3 down here. Okay, and we draw the sine of 3 times y equals 3 sine 2x. Okay, and what color have we been drawing that? Green first. Okay, so sine goes like this. Okay, so there's the sine. That's 3 sine of 2x. But now we have to shift this green graph to the left, pi over 6 radians. Okay, so that's wonderful. So we just go ahead and move this over to negative pi over 6. Negative pi over 6. That gives us that point. But we have to go pi over 4 minus pi over 6. Minus pi over 6. And we're back to that, getting a 12 in our... I said pi over 4, but I read pi over 6. Pi over 4 minus pi over 6, because we have to know where this point goes. And then, so that's, again, our 3 pi over 12 minus 2 pi over 12, and that's 1 pi over 12. So we have 1 pi over 12 is right there. Okay, and that's going to be our high point right there. Okay, and we can keep doing this, and we're going to need to keep doing this. Our pi over 2 minus pi over 6. We can do this. We know the unit circle. Pi over 2 minus pi over 6, well, that's pi over 3. Okay, so that's an easier one. Pi over 3. Okay, that's going to be an x-intercept. 3 pi over 4, though, on the other hand, 3 pi over 4 minus pi over 6, and that is, we get a common denominator of 12, so we have 9 pi over 12 minus 2 pi over 12, and 9 minus 2 is 7, so we get 7 pi over 12. And where does that go? 7 pi over 12 goes there. I had to pause the video. My daughter just got home. I wanted to go say hi. So I'm not sure exactly what I was saying, but I'm pretty sure I just got this 7 pi over 12 x value, and that means that that is where we have a negative 3. Let's put that negative 3 down there, point. And then we have one more point. We have that pi minus pi over 6, and that's going to be 5 pi over 6. Is that right? No. Pi minus pi over 6. And 3 pi over 6, 3 pi over 2, pi over 3. So we have pi minus pi over, yeah, it's going to be 5 pi over 6. Why did it seem wrong? It didn't, it's not. So 5 pi over 6, sorry. I get all flustered when my daughter gets home. Haven't seen her all day. Anyway, right there, we have our last point. So we have 1, 2, 3, 4, 5 key points on the graph of y equals the sine of 3 times, again, we're graphing 3 times the sine of 2x plus pi over 6, and that's going to look like this. Okay. These are so tedious, and we are almost done. Okay, now that we have that, we know that we have vertical asymptotes everywhere this graph hits the x-axis. Okay, so we have at negative pi over 6, we have at pi over 3, we have at 5 pi over 6, and we know we have the low points. Oh, I think I did that in green over there. I'm sorry, I should have used the same colors as before. But the low point here on the cosecant graph would be right there. It goes up like that, and it goes down, yeah, right down here, like that. Okay. So, there you go. Let me draw that a little darker so it totally stands out. Make sure it stands out. This is our final product here. There, like that. Okay, there you go. And the coordinates of this point right here are 7 pi over 12, comma, negative 3. Okay, that takes care of number 12. We are getting there. Sine, oh, okay, so I have to shift it up one. Anyway, let's go ahead and keep going here. No, I'm not thinking that I might not have enough time to do this one in my 15 minutes, so I will start another video.